Welcome to the final lecture video on the Introduction to Statistics Notebook. Um, in this video, we're going to discuss parameter estimation and confidence intervals. In the previous video, we talked about using the central limit theorem to help us perform a hypothesis test. And we gave the example of if you and I made a wager about the average salary of people in the US without advanced degrees. And in our case, we found that the null hypothesis that people without advanced degrees make $70,000 a year was false to a threshold of significance of 10%. If that's the case, we might be interested in answering the question, how much do people without advanced degrees make in the US? And then we're asking a question of parameter estimation. We want to estimate what the average salary of people without advanced degrees are. And just like in hypothesis testing, we don't just want to calculate an average because we've already done that. That's very simple to do. We would like to say something about how confident we are. We would like to attach a probability to our estimate, stating essentially that, the sample mean is somewhat random. And if we drew more and more samples, we would see different means. But we want to get an idea of where the range over which we might expect the sample means to vary. And what is the probability of the actual average salary lying between, some upper and lower bound? So if we can use the central limit theorem to calculate the probability that a sample mean appeared, by or was found by random chance, we could also ask if I moved my new assumption, if I made a new assumption that the sample means were distributed centered on my sample mean, so if I shift this central limit theorem to be centered around this blue line, I can ask what would be the bounds for 90% or 95% or 99% of the probability in that distribution. How far would I have to go to the left and to the right of my sample mean before I got 90, 95, 99% of the area under this curve? That's the idea of a confidence interval. So if I center my central limit theorem distribution on my sample mean, just above $60,000 a year, I could equally well calculate how far to either side I need to go to capture 95% of the probability. And in this case, it turns out that 95% of the probability of this central limit theorem distribution lies between a lower bound of about $50,000 a year and an upper bound of $71,000 a year. Interestingly, this tells us that since $70,000 a year falls within the 95% confidence bounds, there's only 2.5% probability over here, 2.5% probability over here. So if we had set our threshold of significance somewhat lower, well, of course, we already know the p-value is 0.04. So we know how low we would have had to set the threshold such that evidence would not have been significant. But the point is, you can also you do hypothesis testing by calculating a confidence interval. Um, there are some details to watch out for in terms of one versus two-tailed tests, which we also won't be discussing in these lectures when doing a confidence interval hypothesis test. But yeah, there's not much more to say about that. This video will probably be pretty brief. Just to dig in a little bit as to how I calculated that confidence interval. I first of all established the level of confidence I wanted, 95%. And then I can calculate the z-score that I need for capturing 95% of the probability on either side of 0, or symmetrically around my sample mean. So if I take the standard normal distribution, this PPF method is going to return the value, the point on the x-axis, where however much probability I ask for is captured. So if I ask for 1% of the probability, or 1% of the area, if I go from minus infinity up to negative 2.3 on the x-axis, then I capture that 1% probability. If I want 5%, I have to go further right to minus 1.6. So I can ask where, for instance, 97.5% of the probability would lie. And that would be over at 1.95. And in fact, if we look at the value of C, it's exactly the same. So here I've done a little calculation. 1 plus 0.95 divided by 2, you'll find is 0.975. So that gives me the bounds on the standard normal distribution, negative 1.95 to 1.95, where I'll find 95% of the probability trapped or captured in between. And those bounds are essentially z-scores. So I can convert them back into back to salaries by simply reversing this z-score formula. So I would take that 1.95, multiply by my standard error, and then add my new assumed true mean, which in this case is actually the sample mean, and that'll give me the upper and lower bound for my confidence interval. And in fact, if we look at this formula here, we see we take our sample mean and we're subtracting off C, that z-score bound, times the standard error, and also taking the sample mean and adding those things as well for the upper bound. So that concludes our discussion of parameter estimation and confidence intervals, as well as statistics in general. Don't forget, I'll also be uploading a video introducing the DW Mini project and sharing some tips and things to look out for. So make sure that you also check the lecture video list for that. And I'll also be adding that playlist of statistical tutorial videos from other sources in case that you find that this introduction was a little too brief or too confusing, just to point out some other resources available to you.